So we are back. It's lesson 1, part 2 of JavaScript frameworks. And we've kind of done our course overview, done a little group research, getting a sense of our technology stack. We've talked a little bit about mean and what it is. So I'm going to fill in some of the gaps for you. These slides are on Blackboard in the lesson 1 folder. So we've talked about the mean stack. I love that, Fatima. That's awesome. So we've got the mean stack. We also have the MERN stack. I know some other instructors, often when Chris or Sean teaches the class, they use MERN, so they're using React JS. Yep, Boogra, you got it. So that is an option. I've decided to go with Angular. Just a little more comfortable with it. I feel I can do a better job in teaching it. React is on my list of things to learn, but the truth is I don't know it well enough to teach. And really, a lot of the skills are transferable. So we're going to stick with mean for our version of the class. So we've already talked about what the components are, and we've talked about centralizing of using JavaScript throughout the stack. We know what MVC is. Yes, that's definitely true. Yes, there's also the Maven stack, Sviatoslav, so you could use Vue as an alternative in a front-end framework as well. Angular is definitely more object-oriented. React also has, one of the things I really dislike about React is the injecting of, we write a lot of HTML markup inside of our logic components in React. So React doesn't have as clean of a separation. With Angular, the separation between the front-end client UI and the back-end server API is very clean, which I prefer the structure of. I really don't love the way that React kind of mixes those. So we know what model using controllers are. Even Fatima, I know you were in class yesterday, so I know you're doing the .NET class at the same time. So our models, again, handle our data manipulation, our views are our user interface, and then our controller is kind of the messenger in between. So just a little bit of a different visual of how this works. So the controller manipulates the model or the data. The model then updates the view. So one of the great things about using JavaScript is because everything, even our data, is in JSON, we don't have to go through this process of serializing and deserializing. So what does that mean? Well, let's think back to our .NET class, right? We had data stored in SQL Server in a native SQL Server format, and we're using C# classes, C# models to interact with that data. So there's a performance, there's a conversion that needs to happen when we, let's say, query a list of customers out of SQL Server in order to convert that into a class object that, yes, I am. Thank you, Adam. Thanks for checking. So there's a conversion cost to move data from our app between our application and our database. That conversion cost, that serialization and deserialization, it goes away when we're using the mean or MERN stack because everything is JavaScript, including the data. So that gives us a performance boost. So we've worked with JSON before, and it's our modern standard for building APIs. We built the web API using ASP.NET, and MongoDB stores our data also in a form of JSON called Bison, binary JSON. So ones and zeros, which means it's super fast. And, sample JSON, where we've got basically key value pairs here. So visually, this is how the components of the stack fit together. So we've got our client on our front end. We have MongoDB. We'll have MongoDB in our back end. And then Node handles the kind of request and response model. Express will sit between Node and the database. And then later on, we'll use Angular as our front-end framework so we can build a single-page application. So Node has kind of an interesting history. It's actually been around for a while now. It was actually created by an engineer named Ryan Dahl who worked for Google back in 2008. And there's actually a video. It's an interesting video. It's worth watching, but I'm not going to play it in class because I think it's 49 minutes long. And it was when Ryan Dahl he created Node and he introduced it to a team of engineers at Google in like a tutorial, and they filmed it. And it was based on when Chrome came out with its version 8 of the JavaScript engine. It was obvious that JavaScript could run much faster than it had previously. And it actually compiled JavaScript to machine code. And Ryan Dahl decided to try this new idea, which was non-blocking sockets in JavaScript. So underneath the hood, Node is really C. They took the engine and they created Node.js. So Ryan Dahl's talk, where he kind of explains how this idea for this whole platform came to be, it's pretty interesting. And like I said, it's not great quality video, but you can find it on YouTube relatively easily. So we talked a bit about Node using an event-driven model. So we register code to a specific event, like let's say a button click or an HTTP request, and every time that event is emitted or occurs, our code can execute. So this is part of what allows us to run our code asynchronously without it blocking. So I'm going to pause the video here. We're just going to watch a brief video from Code School. The video is old, but it explains really nicely how asynchronous code works and how it's different between how it differs from synchronous or blocking code. And then we'll come back and probably reference a number of the points in the video when we do our examples in a little bit. So turn my screen share back on. So one thing you'll notice is that we've got this strange syntax that we haven't seen before, right? We've got a function, an anonymous function. This function has no name, but it's being passed to this function as a parameter. And as he explains in the video, this is called a callback, and this is the key to Node's asynchronous nature. Now, this syntax works. It's a little bit old. I mean, this video is 8 years old. So we now have a more modern way of writing this syntax that's a little bit shorter, but it uses the same structure. So anyway, we're going to try this out, but we're going to do an even simpler example first, and then we'll kind of do our own version of one of the examples in the video. So first thing we want to do is let's make sure that Node is installed on our computer. So to do this, you'll want to open up your Windows command prompt or your Mac terminal, Mac or Linux terminal. So in your search bar, if you're on Windows, you can just type CMD, or you can open the Mac terminal. So I'm just going to open my command prompt. And just to check it, I can just type node -v. -v stands for version. So this should tell us which version, if Node is installed on my machine, and if so, which version of Node. So I updated my Node this morning, and it shows me I have version 14.17.6. If you have a different version, that's no problem, as long as you don't get an error and it shows you some version. If it doesn't show you anything, then you need to run the Node installer again, which doesn't take very long. But you should be seeing what version you have installed. There's a version of one other thing that we can check, which is one of the other things we're going to use a lot. We'll work more with this next week, is NPM. Anybody heard of NPM or know what it is? You've worked with NPM before? Yeah, it's Node Package Manager. So this is very similar to the NuGet package manager that we used in ASP.NET. In fact, NPM is older, and NuGet is kind of Microsoft's copy of the idea. And what's the purpose of a package manager? You think about how we used NuGet, for example, in our .NET class. Yeah, it's for adding third-party libraries. So maybe we want to do something like add Google sign-in, right? We don't want to write all the code to add Google sign-in. We can go find a package that will do it and add this library using NPM, or if we were doing .NET, we would use NuGet. So we'll play around with NPM next week, but we can check the version of this as well. So if I do, again, NPM -v, it shows me that, again, I updated this morning, so I've got version 6.14.15 of NPM. And NPM comes with Node. We don't have to install it separately. When we run that Node installer, it also gives us NPM. Okay, so now let's start to play around. We're gonna build a few files in Node and try them out. So I'm gonna open up WebStorm. You could use WebStorm, Visual Studio Code. I mean, you can even do this in Notepad or any text editor if you like. But I'm gonna open up WebStorm. I'm gonna create a new project. Now, by default, it wants to put it here in C users, R Freeman, WebStorm projects. That's probably okay. So I'll just call this, I'll just call it lesson 1. And I'm not going to put any spaces in it. It doesn't really matter where you put it. So you can put this in any directory on your computer. The path is not really critical. So I'm just going to create a new folder called lesson 1 and click. And it's just going to be an empty project. So we're going to create the world's simplest Node file and run it. So I'm going to right-click my folder. I'm going to make a new JavaScript file. So most of the files we make will have .js extensions in our course. So I'm just going to call my file. Of course, I'll call it Hello World with no spaces. And I can give it a .js extension, but because I've said it's a JavaScript file, if I just call the file Hello World, WebStorm will automatically give it the .js extension for me. Right? So I just hit enter and I get a file called hello world.js. And we are just going to print a message to the console. See if I can make my font bigger. We'll try 18, see if that's. Why didn't that work? Bear with me. I know the file looks maybe a little bit small. I don't actually think it does, Boogra in WebStorm. I'll have to see. Yeah, it's not getting any. Oh, the editor's getting bigger, but not the. It's not actually the code. It's like the menus and stuff are getting bigger. Editor. See there, font. Yeah. Okay, there we go. That should make my code bigger. Okay, so we'll just use console. And notice it gives me these nice little JavaScript code prompts, which is one of the things I like about WebStorm. We'll just print out a message that says, hello world. I can terminate it with a semicolon. It's no longer required in JavaScript. So now how do we run this file? With Node, we have to use our command line or our terminal in order to run our files. So down here in WebStorm, I've got this terminal window. And to run my file, I can just run the command node hello world. Now I could put on the .js extension, but I don't need to. So there's the command. We're going to run it in the terminal. And it prints out our message. Nothing too complex so far, just a general JavaScript statement, log to the console, and we use the command node and then the file name, and it will run our file. Any questions so far? Pretty clear. Okay, thanks, Chris. Thanks, Adam. Okay, now, most of the time we want to use Node to actually create web pages. So this works, but this is just like a console. How do we actually build a web page using Node? So we're going to write a really simple example. So I'm going to make a new JavaScript file. Again, I'll just right-click my lesson 1 folder. I'll make a new JavaScript file, and I'm going to call this web server.js. Again, I don't need to enter the extension. It's already automatically going to get a .js extension. So make a new file called web server. The name of the file is not critical. I could call the file anything I want. So this file is going to be a little bit more advanced. First thing we want to do is reference Node's built-in HTTP library, run a local web server. So when in your other web programming classes, when you did PHP, we had to install a separate web server like WAMP or XAMPP or MAMP and serve our pages that way. In ASP.NET, we use the IIS Express web server, which was built right into Visual Studio. With Node, there is a built-in server, but we manually have to include it in our code. So we're going to make a reference to the HTTP library. So this is installed when we install Node. So Node comes with a whole bunch of libraries or packages. I'm going to ignore this warning. I'll have to add my Node linting later. There, enable coding assistant for Node.js. So we're linking to the library that called HTTP. And then we want to use the HTTP library to start a web server and listen for HTTP request events. So we talked about Node's event-driven programming. So every time the user hits a URL on the server, that's creating an event that's an HTTP request. So WebStorm recognizes from this package, there's a method in here called create server. And our create server method has two parameters. There's an HTTP request that comes in from our user, and there's the HTTP response that our server is going to send back to the browser. So we've got this funky syntax we'll have to talk about. I've got two parameters here. I'm going to call my first one REQ for request, and my second parameter is RES for response. So we're going to listen for request events and send an HTTP response. So now we're going to use this callback syntax. This is going to be an asynchronous code block. It will run continuously, listen for requests, and send responses. So I'm going to use an equal sign and a greater than. Anybody seen this? Have you worked with these? Well, I mean, we worked with them before in ASP.NET. What is this called? An equal sign and a greater than. What the heck does it mean? Yes, Booger, it's a lambda or an arrow function or a fat arrow function. Yep. What the heck does it mean? Yep, it's from, thanks, Chris. It's from ES6. So what does this mean? Yep, it represents a function. It's a shorthand. It's important. We're going to use these lambdas or fat arrow functions every week in Node. So I know it looks weird right now, but we'll become familiar with it. Let's look at a quick example before we finish this function, because it's important we understand this syntax. I know it may look strange and unfamiliar. That's okay. So let's look at a simple example. So I'm going to write some JavaScript here, kind of like traditional JavaScript. We'll say, variable result equals function and we'll say return a plus 100. Right? So this function, it's an anonymous function. It has no name. But if we pass in a number, our function will add that number to 100. Okay, so this is kind of a traditional anonymous function. So then we'll log out. So if I run this code, what should the output be? What'll happen when I execute this JavaScript? Right, so Adam's saying we're going to pass 30 in as our parameter. It's going to add it and return that value, and then we're going to log it out. So when I run it, right, we get 130. So we have a function, but our function has no name. We're just assigning it to a variable. Now, what does this have to do with our Lambda expression? This is basically just a shorthand syntax so that we don't have to write the word function. So here's our alternative with a lambda. So I'll make a variable called result2. And we can actually write it this way. So much clear this out. So notice this code, it executes the exact same way as this anonymous function. But syntactically, we can replace the word function with a lambda expression after the parameters. And then we can use that parameter in the function. So these are equivalent, but this is the syntax we will see in modern Node code, just because it's shorter and cleaner. There are some small technical differences that have to do with variable scoping, but for our purposes, these are largely equivalent. Now, if we look in the tutorial, again, because the tutorial is 8 years old, at the time this video was made, Node didn't use lambdas. So here in our callback, we see the word function before the parameters. So this tutorial was using this style of function declaration. we now use this style with the Lambda, and the word function isn't here. So this equals means this is an anonymous function with two parameters, a request and a response. So first we want to write HTTP headers with a 200 OK status code. So before we write any text to the browser, we're going to send a header with the status code of 200, which means OK. So we'll take our response parameter that we defined here on line 5, and we are going to write the header. So we're going to pass in 200. We're also going to set the content type of our response. And we're just going to send a plain text response. We then want to print a message in the browser. So we'll use res.write. Hello world. And then we'll end the response. So each time we get an HTTP request, we're going to generate our response, write a header, write hello world, and end the response. We have to do one more thing to get this code to run. We have to tell our web server to listen for requests. And we have to supply a port number. We can put in any port we want, but I'm going to use port 3000 because later on when we add Express, when Express handles the web server, the default port for the Express web server is 3000. So in this course, it'll just be commonplace we use port 3000. We can change it and run our server on another port if we want, but typically we'll use port 3000. So I'll save this. I'll put this code up. So here it is if you need it in the chat. But a good idea to try to type it, you learn it, you internalize it much more if you actually type the code than if you just copy and paste it. If you need to reference anything, I've put it in the chat. Booger, yeah, there would be a default port for React, and it's probably 3000 as well. Again, you can override it, but 3000 is probably the default. So now we want to try and run this file. So if I go to my browser and go to localhost 3000/web server, let's try and run it. Okay, we get this. Cannot establish a connection. How come? Why did I get this result? Thank you, Adam. It's not running, right? It's trying to hit this server, but the server isn't running. So how do we fix this? How do we launch this? Thank you, Adam. We'll do node and web server. So notice now, before, when we ran the first one, it just printed our message and we got our cursor back. Notice now my cursor is just blinking. And that's because the server is active and it's listening for request events. So if I try again, here's our hello world. So now we have an active web page. So we can see the hello world. We can see that response.write command we wrote on line 8. That seems to be working. What about this write head? Let's take a look for a minute where that comes into play. If I open my browser tools, if I open my browser, oops, sorry, not the browser, console, my web developer tools, and I click on the network tab, if I reload the page, here's my 200 status. So there's our status of OK, and type is text plain. So that's our line 7 where we're writing out that 200 status code. Shows up here. Now we're going to do one more little quick thing with this file. How does it work if I want to make changes? Let's say we want to change the message. So I'm going to go back to my code editor, and I'm going to add in our first node page. So I'm just changing the response on line 8. I'm just changing the text here. So instead of just saying hello world, it now says hello world dash our first node page. So I want to go back to the browser now, and I want to see my changes, that we should get a different response in the browser. So I'm going to go back here, and I'm going to refresh, and page didn't change. How come? I've saved the changes in WebStorm. Our message should now say, hello world, our first node page. How come when I reload my browser, it's still just showing the original message of hello world? Yep, that's right. Thanks, Chris, Cam, Adam, you've all got it. Because our server is still active and running. Right? It's locked. So I need to stop the server and then restart it. So to stop my server, I can hit Control-C. And now notice it brings me back, it shows the path, and I have a flashing cursor once again. So to restart it, I need to run the node web server command again. There's two ways I can do this. I can retype the command, node space web server, or if I use the up arrow on my keyboard, when you hit the up and down arrows in your command prompt, it will show you the last command. So if I just hit the up arrow, it reprints my node web server. Now I hit enter, my server's running again, and now we can see our change. So this is a little bit inconvenient to keep stopping and starting the server each time we make changes. Next week, we'll use an NPM package that will do an automatic restart. It will watch our project for changes. And every time we hit the save button, if any file has been changed, it will automatically restart the web server for us. So this week, we'll start and stop as we're making changes. Next week, we'll add that utility, that NPM package in to do what's called a hot reload. So our server will just restart automatically with changes. I'm going to do one last thing with this file. So again, I'll have to, one really simple thing. When our server's running, we just kind of get this, we get a blank cursor, a flashing cursor in our terminal. There's no indication here that this is running. So I'm just going to add one more line here. Print message to console to show server is active. I'll just use console.log, say node server running on port 3000. So this time when I launch the server, not only will our page load, can we view the page in the browser, but we're going to get a confirmation message printed out here in our terminal. So again, I'll hit Control-C to stop my server. I'll hit the up arrow. And when I hit enter, not only will my server start running again, but it's also going to print this message. So the server's offline right now. If I reload it, it's going to time out because the server's been stopped. So if I run my web server one more time, right away we can see, okay, cool, server's running on port 3000. So our line 13, it's been printed out. And now when I refresh, our server's back online. We can load our page, make our HTTP request, and get our HTTP response. I will put this code up on GitHub in just a minute. I can start to do that. For the first few weeks, we'll probably create separate repositories. And then by about week 4, week 5, the rest of the semester, we'll build one project. I will make a new repository. So this is 2068 L1 public. So again, I need to stop my server here so that I can push this stuff up to Git. So I'll do git init. Dot. So this is lesson 1, part 1. First node files. Get this stuff up on GitHub for you. Okay, so all the files are on GitHub. Um, 12:52. So we're due for another break. I do want to do 2 more files. I want to do a blocking and then a non-blocking example after we take a break. Does anybody have any questions before we take a short pause?
Yes, Professor. Sorry, I feel like something wrong with my HTTP library because like function create server write head, it's like unresolved function in my code. I have a problem, code error.
Okay. So yeah, the code editor may say unresolved. Just ignore that warning. You should still be able to run it, even if the code editor doesn't recognize it. That's okay. So try to run it anyway. Repeat, it's not critical that you put your code on Git, but if you need it, the reference is here on Blackboard. So under Weekly Learning and Tools and Resources, here are the commands. Okay, so these are here for you to reference anytime you need them.
Okay, so I will try run. Thank you.
Okay. All right, so I'm going to stop this recording and step away for a couple minutes. And we will come back at 1:05, and then we're going to do our blocking and non-blocking examples. Okay, so I'll see you back here in 10 minutes. Okay, Kripa, we can look at that. It's not critical. It's helpful to have the coding assistance. So if you have the option, click on it and it should enable it. But if not, we can look at another way. But it's not critical for today if it's not working. Don't panic. We can sort it out.